Hey, I think that's the fastest I've seen someone join my stream. Nice to see you, Johnny. Oh, you got me on notifications. Ooh. So, I left off with the schematic. I did, during John's stream, manage to go back through and finish updating my library, so all these components are correct and have their footprints, so I can do a PCB for this one now. But instead, I want to do the second schematic first. And that one is here. Probably copied over something old. So let's delete all the old stuff. And I think most of this I don't need. Well, actually. Do you want this stuff? Don't need that. Let's get rid of all of this. I'm actually going to use a different regulator because this portion is for the motion gloves. So they are battery powered, and at least for the one use case for them, the presentation would only be an hour, so it doesn't need to be that efficient, but I might as well make them efficient. The batteries I want to use are like, I think they're 2000 milliamp hour, so more than enough capacity. The next best ones I can get my hands on are like, they're under 1000. So unless they end up being really bulky and I don't like the feeling of them, although I'll probably put the battery on my arm rather than being on the wrist with the controller. So I might make the gloves a little longer to put the battery in. But if I find it too uncomfortable, I will probably check what the current usage is like. Which one of these days I will buy by the Nordic power probe. It's been on my to buy list. because I have another project that needs them. Needs good power monitoring usage. I should probably switch my camera view. There we go. So I was showing the other schematic beforehand that I realized I didn't switch my screen view for. But it's all done. And I've updated the library, as I was saying. So I want to get the next one ready. I want to make sure I know all the categories I need. So MCU. Battery charging. I need USB. Need motion. Need haptics. We need ADCs. And motion. I think that's everything. Oh, I need LEDs. Let's switch this to battery. And under battery, we'll have both charging and monitoring. The charger, I believe, is the MCP 738301, 831, and then for the monitor I have the Max 17648. I've got the flux sensors as well, which I have not decided which one to use. Let's put it in. So we have I was looking at a few. I was looking at EDS 5. So there's this one, and then you have this one, and there's this one. So, what I like about this one is that it has 8 channels. The only issue is it's an 8-bit ADC. And you have 5 that are going to be used on the hand. Then you have this one. Programmable gain is kind of nice. But the big thing is it's 16-bit. And then you have one that's 12-bit. So, yeah, fun times. What's the spec on the flux sensors? I think the specification on these flexible sensors is why I wanted the higher bit rating They don't have to be read too often, at least in my use case they don't. Although I suspect that it's going to be such a low level thing that reading it often enough wouldn't be much of an issue. Specifications. So in normal state it's roughly 25 kiloohms. The tolerance is 30%. Whoa. Its potential resistance change can be from anywhere from 10k to 125k. So like that's a huge window. How many bit ADC do you want for a flex sensor? 10-bit is generally a good choice, offering sufficient resolution for most applications. Uh, 12-bit can offer more precise readings, but they can be more complex and expensive to implement. 10-bit is a good balance between accuracy and practical considerations. And then there's one on the Arduino forum, which of course is recommending this. Yeah. How much is this going to cost me for prototyping? Although, to be honest, I don't really expect I'm going to need to use the pinky very often. So I could probably limit the number of sensors if I wanted to. Just seems easier to add it and not need it on the coding end. Or I guess you could add a force sensitive element inside the glove for tapping a finger against a pad. Might be an option to at least use up a couple ADC spots. Let's see. Something like this in the palm of someone's hand, and then that way I'm not only just monitoring my finger moving, but if I wanted to trigger an extra action, I'd be touching a pad. Sensitivity range is 30 grams. Not even sure if that's enough. Oh, we just have to add it and test it. And this is 1 to 100. 0.3 newtons. I don't feel like that's enough. Yeah, I think it would work. So, let's check GLC PCB for the ADS. How much is this gonna hurt the piggy bank? 138. It's not bad. VSOP chip. They have it in QFN. And look at the jump on price point on that one. Woof. QFN would be nice. Although, does the circuit board have a decent amount of space on my palm? Well, not my palm, but the back of my hand. And like I said, I could always move the controller and battery up higher on the arm and wrist. That'll come down to actually designing the circuit board. So we do it with a VSOP. Save a good chunk of money. Now we go to the 12-bit. How does it compare? So same price there, but half the price in QFN. So if I need the QFN, I would have to switch. They have more stock quantity available. So, I think that gives me my answer for that. Haptics. I actually have a project that has haptics in it already. I also have a project with the power supply that I want. So let's open that one. This is a small regulator. So keep that for the power supply. This one needs to be updated in my library at some point. I'm not going to use the raw MCU. I did a test layout in this project actually. It doesn't actually use that much smaller of a space. So I'm going to use the regular module. It's probably not fully optimized for battery, and the only thing that really would be the stuff by Unexpected Maker. But I'd have to buy those and solder them on separately, and I don't particularly want to at the moment. I want it mostly self-contained if I can. Like I said, the current expectation for the battery is the battery's going to be oversized, so shouldn't be an issue for runtime. Next one to copy over is this one, which is our MCU. Removed. I'll find that haptics one shortly. Put that one there. The reason I'm copying that one over is those ones are updated with my most recent libraries. This makes it a little easier to put them in place. Don't need 5 mounting holes. I probably don't need 4. The logo can be updated. Put them over to here for now. And then the other one is USB-C. So use that as a source of incoming voltage for programming. Yeah. Sorry, for battery charging and stuff. And then let's find the project that I put the haptics on. haptic. This way, it can rumble when I'm doing different triggers. I can know what mode it's in, as well as knowing that it's actually working. I wonder if it has the ADS built into kicad. Be 1115. It's a V sub. GLC. That is ADS 1115 IDGS. They're the same. Gonna pull the data sheet. Of course, it's not in English, so that doesn't help. 2.9, 2.8. listed as VSOP. Just to be safe, I'm gonna set it to VSOP instead of the TSOP. And I need 2 of those. I don't think... Look for a 2-pin connector. Connector generic with mounting pin. 2. Do I have footprint for JSTPH? JST. Move this over here. Vertical. I have a 3D file for this one, so I'll probably end up putting it in my own, and I need to double check. The measurements anyways when I find the available part in LCSC's catalog. Leave that there for now. We already have haptics in place. USB is in place. Motion is what's that? 6D. Should confirm that it's the right part. Let's keep that one open. Looking at the LSM 6DSOX. Okay. Ooh, thank goodness they have that in stock. That's a small chip. My goodness. LGA 14, 2.5 by 3. So, I want to confirm the footprint on it. Yeah, that'll work. Can I move this over? Oh, I can. Okay. Right. Do that. So, we got pin 1. Yep. Pin 2, SDX, SXC. Int 1 is pin 4, correct? Int 2 is pin 9. Correct. VDDIO. Pin 5. Pin 8 is VDD. Correct. SDA on 14. Yes. SCL on 13. Yes. Pardon me. Chip select on pin 12. Ground on pin 6. It probably has a hidden thing where it's connecting 6 and 7 together. Looks correct. 3 by 2.5. The same thing, I think. Okay. So ADC is here, motion here, and then we have WS2812. Ooh, they have a footprint for 2020. Let's see. WS2812. So 50/50. 2 by 2. 4 is data. Let's move that over to there. Okay. Data in is pin 4. Cool. That's it backwards, I think. Nope, that's the 5mm version. Let's go to that version. There. Pin 4 is VDD. Yeah. Pin 3 is data in. Ground is pin 2. Data out is pin 1. Yep, that's the correct footprint. So should be able to use that for the LEDs. And I'm going to have a few of them, so let's do 1, 2, 3. And I was going to make it 5, let's make it 6. Let's add the transistor. So I'm going to turn them off. That leaves the battery charging. So, first one on the list is Max 7. No? 17648. It's not there. The next one is MCP 73831. Ooh, this one is here. I was really expecting to have to download half of these items. It's nice I don't. Man, I always end up with a half a dozen tabs open. Goodness gracious. Keep that one open. I know why I'm keeping some of them open. It's because I'm going to refer back to this is what I like with Adafruit. The schematic is there. A known working schematic. Next one, Max 7648. Use it as a fuel gauge to internally monitor the battery with better accuracy than just using a resistor divider. And then for charging, it's PE 73831. Where did I see this being used? Is it on this? Ooh, thermal imager on sale. Yeah, I think I got the attachment there. Built-in 200 milliamp hour charger. Let's go. Power comes in. And charge. Here we go. Ooh, goodness gracious. $5K is 200 milliamp charging. I'll probably go with the 10K. I don't really need rapid charging, and it'd be nice to the battery, especially if I decide to change the battery. 73831, yep. -2. Looks like the correct one. To ACI OT. I believe that's the one I want then. Prog on pin 5, VBAT pin 3, SS is pin 2, VDD is 4, stat is 1. Yep. That'd be the one I want. And then the monitor chip. Monitor. Think the best option is Max 176. Is the right one, I hope. Oh, 17048. My crappy handwriting looks like a 6. Well, this one is going to require adding it to the library. So I better confirm which one GLC has. It's going to be this one, which is the DFN. G plus T10. Let's be this one. ECAD models. Fantastic. Download in kicad format. pack all of those. Good, it didn't have the 3D model. But to be honest, I shouldn't be able to use that. Pin 9. It's the E-pad. Small editor. Yeah, put it under ICs. Import symbol. Hate when text is over sitting on top of things. Oh, goodness gracious. And it's supposed to be DFN chip. DFN 8. DFN 2x2mm. That's a really large pad. Can't tell if it's supposed to be the small pad or the large pad. It looks like it has a big pad on the chip. Ah, here we go. 2x2 pad. I think I need to open the data sheet. When did we start making data sheets without the footprint information? Like, jeez Louise. I thought this was a good idea. I'm noticing it in more and more data sheets. Oh, there it is. I think. It's a footprint. It tells you the pinouts. It doesn't tell me the downsizing. So for this company, they put it in a secondary document because of course they do. So the pad. Well, actually, let's do the part on its own. E and D. So it's 2mm by 2mm. So this is correct. It is the pitch. It's 0.5. The pad. At its largest, it would be a 0.8 by 1.6. Be too large. 0.6 by 1.2. Fit both of them. Wow. Make a variety of different sizes for this one thing. Only need to standardize it. My goodness. 0.7 by 1.2. But it's a smaller chip. So I'll go, that's the closest sizing. I'll put the LCSC number in because this is my own library and I don't want to have to redo it a billion times over. that's that part. And what's that? There we go. That's the battery monitor. I think that gives us all the components necessary to make this work. Start in the areas that I think are going to be easier. That all connects. We add a do not connect flag there. And we'll have to add a way to control LED power. Now for these, let's be in the off state. pretty sure it gets pulled up. It's pulled up. I need a 10 system. This one I'm not gonna put the connector. I don't think. I think I'm just gonna do pads. One without the mounting pins. I need a 10K resistor. I'm not even sure it's worth putting power cycling on this. Like, yeah, the LEDs can use a fair bit of power just sitting, even when they're not lit up, but these gloves aren't going to be used often enough to want the power saving and paying for the extra components. So let's simplify this. that's the LEDs. Uh, let's do... Maybe I'll focus on this battery first. So... Okay, well, so following the schematic, we have the battery coming in, and we have a ground connection. This so it's a ground. Step pin. It's for charging. No, plug. Let's change this around. Step pin. 10K resistor here. And put the LED. And then power. And that power comes from here. And program pin, I'm going to use a 10K. And then also attached to the battery is a 10 UF capacitor. So there's your battery connection. And then next one would be the fuel gauge. So if we look on this, an extra component in here. What component is this? P-channel FET. Let's move this diode. Hey, Keith. So the battery connection. Goes to there. And also wants a capacitor. It's weird. This one doesn't mention if they connect the e-pad down to ground or not. Better check the data sheet. Okay. E-pad goes to ground. These all need to get moved around. Those go to ground. These are both positive. That, well, it goes to ground. Data. Those can go up there. Q start can go to ground. No, will probably go to ground. Oh my goodness. Half an hour and it's John time already. Oh gosh. Okay, that all goes to ground. E-pad to ground. No BBQ today, Keith. There's no barbecue happening. The alert pin, make it to 10K. John actually has a new web page for it as well, because obviously not everyone's on Discord a lot. Go grab the link for you. There you go. For future reference. That goes to VCC. So I'm assuming that would be my 3.3 volt communication rail. Does this not bypass power? Oh. So the breakout that Adafruit has for this charger has an input and an output connector on it. And I thought for whatever reason that this chip might actually be doing current monitoring as well, but it's not. It's just a monitoring chip. Just still fine, it'll meet my needs. Just good to know. And then I need the data lines. Drop down here. So I got the charging chip, I got the monitoring, I have the battery system, and then we got the power supply, which will have incoming VBAT. Let's do it like this. One of them goes to VCC. The other to the battery. And that way neither one backfeeds themselves. That gives us the power. I think that's everything needed for that to work. I could always add an optocoupler to that, although that would use a lot of circuit board space. And I can tell if I'm charging. Although you could just monitor that. You should notice a difference if it were charging. USB-C up here. So they all kind of flow into each other. Charging, monitor, power supply, USB-C programming. I think the only one I'm worried about is if that power supply is going to have enough power for everything. Let's see, adding a second supply. That and that should be okay, but consumption. Actively uses 85 to 100 milliamp hour. And obviously when it's first booting is when it does that ridiculous draw spike. Pulses up to 400. Yeah, so let's calculate it at, let's say, 150 milliamps for the ESP. Let's go find that LED. Got 12 milliamps per LED. It's 12 times 6 is 72 milliamps. And then for the LEDs, and then the ADS, and then got P. What's that? Max. Oh, the MCP, it's a max chip. It's power usage. Supply current. Oh, jeez. 40 microamps. And so that's really low power. The ADS. Maximum rating is 10 milliamps. There's two of them, so 20 milliamps for the ADC. Doesn't really indicate what it actually uses though, because I ain't no way that ADC is using 10 milliamps. I think that's what it can handle you injecting to it when measuring something. What else? The haptic. Well, let's do the LSM chip first. I want to download it. Looks like at its maximum, it's pulling 0.6 milliamps. That's for motion. The haptics. DOV 2605. Might have the wrong one signed here. Yeah, it's out of stock. Does GLC have it in stock? They do, okay. That's good. So the way it sees it, for motion, you're looking for the haptics, 0.7 milliamps for the IC, and upwards of 4 milliamps for the motor. So we do the math on that. That'll put us at 50. Well, that should be well within the limits of that regulator. That's almost 250 milliamps for everything on here, which the regulator is rated for 700. So, yeah, should be more than capable. If anything, just desolder LEDs. seeing as it's time to switch to John's stream, don't think I'm gonna finish off those two. So I think I'll stop there. Although maybe I will finish off the schematic, and then the next streams will be making circuit boards. So, not bad. Don't need that one. Don't need that schematic. I will need that schematic. What other schematic am I missing? Missing the ADCs. What's the part number? ADS 115. I'll see you in a bit, Keith. Have a good day, everyone. Thanks for hanging out.